Now we're going to get into cooler stuff, or at least find cooler stuff, because up till now, our programs were going to be kind of simple and limited. But we're going to open this up to by going on to arrays and lists. And now when we combine them with loops and methods, it's going to open up a whole world for us. So let's bring back our old silly simple program. And if you don't have it, it's not going to take you long to remake it. But this is going to help us see what an array is. And of course, there's what we've referred to as the strict definition of array. But let's first off start with another analogy. And these analogies are kind of getting old because I have finding less and less things that we own that are physical anymore in the computer world now. So the last thing maybe that I would use is the DVDs. So DVDs, let's say movie DVDs in particular, are going to be stored in a case, right? And you might have to put these somewhere in your house. If you don't, just imagine it for right now. So we have 100 DVDs, and we have a big container that has 100 slots in it. And we're going to put those DVDs in those 100 slots. Well, each one of those slots, if you can think about them, let's say they're all in vertical. So it's just one column vertical of 100 slots. You could number out each one of those slots, right? So you could say, okay, it starts, this is 1, this is 2, this is 3, this is 4, this is 5, all the way to 100. And then it might be easier to find this. And this might start sounding like references here. So let's say in the 55th slot, you have the movie Gandhi. And in the 99th slot, you have Zoolander or something else like that. And then, in the first slot, you have Armageddon Now. So, maybe it's just roughly in alphabetical order, but it's very easy to just tell your friend, go to slot 55 and get Gandhi. Go to 99 and get Zoolander. Well, that's essentially what arrays do, is they will store a bunch of data types or not a bunch of data types, a bunch of values in a container like that DVD case. But, now think of the DVD cases, and let's say you go back, say you find, I don't know, in your grandparents' closet or something like that, the old VHS tape. And you can't put the VHS tape in the DVD container. So that is similar to data types. All of an array will hold a whole bunch of values, but all of the same data type. So in other words, they all have to be integers, they all have to be floats, they all have to be strings, whatever, but that you're stuck with that. You can't mix integers with doubles, with strings, with characters. That's not possible. You have to put them all the same things. And it makes things a lot easier because why rename, if you have, let's say, in like a banking software, you have 15 customers, right? Well, why would you want to store each customer in a different variable name when you could just have a customer array where you can put all their names in there? And that's essentially what databases are, is that databases are essentially these kind of what I would call a two-dimensional array, but what you have is just the storage of this large amounts of information in a unified container. Okay, now let's go ahead and break this down for you. So I'm going to go into the submit button. And I've kind of reversed this program from last time. So you probably have, if you're using your old one, you probably have the int xy, and you probably have these 3 lines. I did change this back to x, and I took the references out in front of the x in this header and the x here in the call, in the method. But guess what? We're not going to look. We're not going to look at any of those right now. What we're going to look at is the talking to an array. And as you can see, the array word is actually not a keyword. So we can actually use that word. All right, so if that's the case, here is how I am going to instantiate it. I am going to put these square brackets, which make sure that the C# and the compiler knows that this is an array. That's it. And then we're going to give it a name. And we're going to say new. And what new does is allows an object to be created in memory. So an array is a type of object because it has properties. Remember, we're going to order these things in a specific system such that we can find things easily in them. So it's not just a simple variable that has a data type and a value. Now it can have a size, right? It can be, in this case, the size is going to be 4. It can be reversed. It can be ordered. So there's a lot of things that you can do to an array. So since it has these properties, then it's better to create it as an object. And the word new will create that object and also return a reference to that array. Because arrays take up, obviously, in this case, 4 times as much space. When you start getting out to 100, that is for this number, then it's 100 times more, and then 1,000, and so on and so forth. They can get pretty large, and it's better to reference them than to constantly copy them. Okay, so let's do this again. So in this case, I'm going to say a data type is the first thing that you write, because everything in here has to be an integer. Then the curly brackets, denoting that it's name equal sign, because equal sign is going to set that object equal to it, or connect that reference to that object. And then new, which we'll talk about again in a second. Int has to be the same data type as before, and then size. You may have seen the word new before. When the word new shows up, generally what that means is it's an object. And so we talk about declarations and initializations. Well, this is kind of how you do it for an array. Excuse me, not an array, an object. Objects do need to be declared, and they need to be initialized. But what we do is we call that an instance. And the reason why it's an instance is because then it becomes a unique structure. So in other words, I can create multiple types of arrays. And by array, I mean this little array. So if I call this thing Bob instead, then Bob can have several instances of himself. So we can make a whole bunch of different Bobs. And in fact, we saw that with the random number back in a few videos ago. So the next thing we'll do, and then I think we'll break for the next video, is that we are going to set a couple of these arrays equal to something. And so our first array that we use is called array, and we give it a 0 and a 1 here. 1 is the value. So 0 is the index. 1 is the value. So we're going to put in array 0 the word 1. And this is where it gets interesting. C# and a lot of programming languages do not like to start counting from 1 up. They like to start counting from 0. So they prefer to count from 0 to 9 to create 10 new spaces, as opposed to count 1 through 10 to create 10 new spaces. In ours, we have this 4-space array that can hold 4 integers. And the first one is going to be array 0, array 1, array 2, and array 3. Sometimes this is referred to as a subscript 2. All of these guys inside here are going to be called elements, or a cell of information. So it's a generic term. Its index is its specific spacing or specific element name. And then size we have up here. And as you can see, these are all specific properties, right, of all the space. And now let's look at these 2 lines again. So 0 is actually our first spot in an array, and given 1. Our second spot in our array is called array 1, and it's number 5. Array 2 and array 3 are going to complete the array, but we haven't defined them, or in other words, we haven't initialized them with any variable. But they exist, and we can define them later. Okay, so that's the definition of arrays. Let's come back and then play with these guys a little bit.